Today we're going to work on adding and subtracting rational expressions. If you look, we're just going to do examples 1, 2, and 3 today, and then the rest of the examples 4, 5, and 6 tomorrow. So adding and subtracting rational expressions and simplifying complex expressions. As a reminder, adding and subtracting rational expressions is similar to adding and subtracting fractions. To add and subtract rational expressions with like denominators, we add or subtract the numerators and use the same denominator. So here we have an example of both of these fractions, the denominator being 5. So you merely add 1 plus 3 equals 4, just the numerators. Same with subtractions. When you have the same denominator, you just subtract the numerators. So let's try our first one, add or subtract. Identify any x values for which the expression is undefined. So I have the same denominator, and I just write down the numerators and collect like terms. I have 2x's minus 5 over x plus 4. That's our answer, and x is undefined at negative 4. Remember, we just take the denominator, set it equal to 0, and solve for x, and that's where it's undefined, because the denominator cannot be 0. That's what undefined means. Another one, add or subtract. Okay, I have the same denominator. Here we're subtracting. So remember, that is minus 6x minus 1. You distribute the negatives. X squared plus 1. So now you collect like terms. 3x minus 6x is negative 3x. Negative 4 minus 1 is negative 5, all over x squared plus 1. And for undefined, if I set that denominator equal to 0 and solved for x, I get x equals I. So actually there is nothing I can plug in to that x that would make that equation undefined, because I can't solve for the variable. If I plug in a negative 1, I square it first, and I'd have 2. If I plug in a positive 1, I square it, and I'd have 2. No, so there are no undefined values. Again, add or subtract. You try this one, push pause. There we go. Look at that and push play. Another one, push pause and try on your own. And there we go. Let's move on. To add or subtract rational expressions with unlike denominators, we first have to find the least common denominator. The LCD is the least common multiple of the polynomials in the denominators. Okay, pause in your head for a second. Multiples mean, if I want multiples of 3, I do 3 times 1, 3 times 2, 3 times 3, 3 times 4, etc. Those are multiples. So the least common denominator is the least common multiple of the polynomials in the denominator. So, to find the least common multiple of polynomials, you factor each polynomial completely and write any repeated factors as powers. For example, if I factored this, first I factor out an x, and then I would factor out the remaining, which would be x plus 3 times x plus 3, which is x plus 3 squared. Then you list all the different factors. If the polynomials have a common factor, use the highest power of each common factor. We're going to practice a few just finding these common multiples. Okay, so let's find the least common multiple for each pair. We have least common multiple. So I'm going to factor each term. And for the first one, I'm going to factor it into its prime numbers. 2 times 2, x squared, y cubed. The second one, 2 times 3. X to the 4th, y to the 5th. Now we need to collect everything. Okay, I have 2 2's up here and a 3 down here. That one's the set, this one is taken care of, but I need the most of everything. So if the first one has 2 2's, I need to include the 2 2's. The second one has a 3, but the first one doesn't have that, so I need to collect the 3. Now, the variables. If you remember that last slide said use the if the polynomials have common factors, use the highest power of each common factor. So we have 4 x's and 5 y's. So our LCM is this. Let's try the next one. Factor the first one. I get x minus 3, x plus 1. The second one is x minus 3, x plus 2. Okay, these are the same, so I only need to write it down once. These aren't included at all, so I need to write them both down. So that is your LCM. Try some on your own. There we go. Check that out and write down any questions you might have. To add rational expressions with unlike denominators, we need to rewrite both expressions with the LCD. This process is similar to adding fractions. So let's look at adding some fractions with unlike denominators. Hopefully that'll refresh your memory to how it works. Okay, these don't have the same denominator, so we can figure out what the same denominator should be. We're going to break up 6 into 2 times 3, break up 10 into 2 times 5. Okay, so our least common denominator, which is your least common multiple, is 2 times 3 times 5, which is 30. Okay, so what we do is we multiply 6 times 5/5, because that gives us 30, plus 3 times 10 over 3 over 3, because that gives us 30. Multiply straight across, I have 10/30 plus 9/30. That gives me 19/30. Okay, so we had to multiply each expression to get our LCD. All right, add. Identify any x values for which the expression is undefined. So let's break this up, factor it. I get x plus 4, x minus 1 on the bottom. So what is our least common denominator? In this first expression, I have an x plus 4 and an x minus 1. In the second expression, I have an x plus 4. So the least common denominator is x plus 4, x minus 1. So we need to multiply that second expression by x minus 1 over, let me write that better, x minus 1. Rewrite everything. I have x minus 3, x plus 4, x minus 1, plus 2x times x minus 1 over x plus 4, x minus 1. Now we're good. Continuing on, collect like terms. This right here is going to be 2x squared minus 2x, which will help us collect like terms. I have 2x squared, a minus 2x and a positive x, minus 2x and a positive x. That gives me a minus x, and a minus 3 over x plus 4, x minus 1. And we are undefined at x equals -4 and 1. And that's our answer. Let's try another one. We need our least common denominator. This factors out to x plus 2, x minus 2. So our least common denominator is x plus 2, x minus 2. That first expression doesn't have an x minus 2, so I need to put one in it. X over x plus 2 times x minus 2, I did it again, over x minus 2, plus -8, x plus 2, x minus 2. The numerator is x squared minus 2x, plus a -8 over x plus 2, x minus 2. Collect like terms. I have x squared minus 2x minus 8 over the common denominator. And we're undefined at -2 and +2. Actually, I'm going to write this equation on the next page and show you how they can be finished if you can factor further. So write that down, and I'm going to move on. I have x squared minus 2x minus 8 over x plus 2, x minus 2. You can factor that numerator into x minus 4, x plus 2. And simplify. I'm left with x minus 4 over x plus 2, and we are still undefined at x equals negative 2 and 2. All right, go ahead and you try this one. Remember to factor the denominators to see if you can simplify your work any. Okay, not too bad, especially if you remember to factor the denominator first. The first time I did this problem, I didn't factor the denominator, and my least common denominator was huge, which made my whole problem huge. So yeah, try to simplify your work. Okay, you try this one. Remember to factor. Okay, let's look at this page before I move over to finish. My least common denominator was x plus 3 times x plus 3. So I had to multiply the first expression by x plus 3 over x plus 3. And that gave me a common denominator. So here I multiplied x times x plus 3, got x squared plus 3x, wrote this down, collected like terms. I could factor the numerator and simplify, but now I'm out of room, so I'm going to turn the page and continue. I have x plus 2 over x plus 3, and we're undefined at x equals negative 3. That's all for today. We'll continue on tomorrow.